Hi, I'm Ken Berman, and I'm the faculty member who heads the QuickSilver project at Cornell University, and we're going to be demonstrating a technology we call live objects. On the left, you see a folder of live objects. They're like small web pages, and these are small web pages that have highly dynamic content because they're linked to an underlying event channel or a multicast channel. For example, here's a chat window implemented as a live object that interfaces to the display and to the keyboard, and after waiting a second, echoes what it sees out on the underlying multicast channel to be shared with other instances. Here's a second instance. Obviously running on the same machine, although the technology is intended to be used in enterprise LANs and even eventually in wide area networking settings. Each of these multicast underlying channels has a notion of a state, and you'll see that when we instantiate a new instance, in this case a second instance of the chat window but associated with a different multicast channel, the initial state is actually transferred over from the other objects, and then updates are seen in the same order by all replicas in a consistent manner. Live objects can support all kinds of replication scenarios and sharing scenarios. The underlying technology is a type of a mashup. We're seeing actually the mashup of objects in this funny little folder window. The way to understand what's going on here is to think a little bit about the way that Google mashups are supported on the web, maps with push-pin interfaces over them. Live objects are a very similar kind of a technology in which small components are connected together, type checked for compatibility, and then the events from one type of object can flow into another. And in fact, we're illustrating that here by creating a live document. It's called a desktop document. We can actually support live databases, spreadsheets, PowerPoint slide sets, but these live documents in any case can contain various sorts of content. So here we have a couple of our text windows shared in the context of a live desktop object, which itself could be shared around, put inside of other desktop objects, put inside of itself. We can support recursion. We'll get into what happens if you do that and don't terminate it. We can support image content, as we're seeing here. This is a little frame that can contain a static image, or it could contain slides that change over time. Videos, audio, any kind of a stream of information is compatible with this kind of a system, and we're going to actually be interfacing it to real-world sensors of various kinds in the coming months. We envision this as a way to rapidly mock up collaboration tools or other kinds of distributed decision support technologies for enterprise settings, businesses, gaming, or other sorts of applications such as a disaster response application that I'm going to show you in a moment. So here we're getting kind of fancy with our live desktop and showing you that you can have the same object used in many kinds of contexts. We've got a desktop 1 inside a desktop 2 by now, and we could actually mail this thing to somebody. Live objects are using an XML-based encoding that's based on web services, which is a standard that's used throughout the web. And the objects themselves are a lot like web pages that tell you what they connect to, and mashed together this way they create a thing that looks a lot like a web page with frames. And I could literally mail that to my friend who would receive the live object and see the exact same state that I'm seeing in real time. His updates would appear on my screen, mine on his, in a total order that's guaranteed to be consistent and fault tolerant and scalable if the technology that we built at least is used for the underlying multicast. We built something called QuickSilver, which is a scalable underlying multicast. So now what we're going to do is to show you a different kind of use that's evocative of Second Life, the very popular multi-user virtual environment. We're going to build a live object folder which contains a collection of objects, and then we're going to superimpose on top of that shared folder, which is going to be the underlying channel actually, a visualizer which is based on Microsoft's XNA 3D visualization technology, and that's the black box you just saw here. And what's going to happen is that the contents of the folder will be visualized by the window. Later we'll have more than one of these windows. So here's, for example, a 3D map object that shows New Orleans after the flood. Maybe we want to build a search and rescue application on the fly, with no programming, by the way. You haven't seen a line of code written yet. Live objects make it possible to build sophisticated distributed applications without programming. So in this case, we're going to be pulling some buildings that need to be searched on top of our New Orleans scenario. You can see the building there, it's black. And the roof of the building is intended to be colored in a way that as we search the scenario, we can indicate through the color of the roof whether or not the building has been searched and if it's got people who need to be rescued or not. Maybe red needs rescues and green means it's clear. We can have lots of these buildings, and each one has its own multicast channel. And as we pull the sliders, we're sending a shower of little multicast messages that say recolor your roof. And the Live Objects technology can actually support literally tens of thousands of messages a second. And so you can really build extremely dynamic, scalable applications. Interestingly, I should mention, unlike Second Life, where all the interactions run through a data center out in California, with Live Objects, data flows directly from the sensors that capture the information to the applications that display it or store it in a database. So for example, I can actually take data directly from a database and make it visible directly on the screens of the users. Right now we've got a couple of buildings, and we've thrown in something else that's live. We've got a sensor that emulates the positions of an airplane flying around over New Orleans. In fact, we're going to put a bunch of planes in. And so there's a GPS coordinate feed mashed up with a renderer for an airplane. And in no time at all, we've suddenly got airplanes flying over our scenario, visualized in real time, and different people sharing the same scenario based on where they were sitting would actually be able to see different parts of it. In fact, we're going to see that in just a moment. We're going to make a second copy of the same window, and we're going to take a slightly different orientation, and we'll see sort of a different subset of the worldview, just like in Second Life, when we're trying to play with that. The technology is designed to scale in dimensions actually that no one's ever really tried to build scalable distributed systems before. We have to scale here in the numbers of superimposed live objects, which creates a need to scale in the numbers of overlapping multicast groups. They all have to provide reliability and ordering and consistency and fault tolerance. We've been doing that with our QuickSilver scalable multicast technology, which we think breaks really new ground in its scalability. So here's that second window I promised you, where we have a second orientation, seeing some of the same objects and from a different perspective. And here's something kind of fun. One thing we can do is to reuse these mashable components up. So for example, I can actually pull the coordinates of airplane 0 into the window, and what am I doing? I've suddenly jumped into the pilot's seat of plane 0. So live objects are an exciting new way to build collaboration applications. I can share them, as I said, by making copies on files or passing them around. Inside the live object, if you look closely, you would find an XML recipe for building the object that tells what's supposed to be above, what's supposed to be below, and where to find the chunk of code to run, for example, that interprets GPS coordinates by re-rendering the airplane. And that code can be downloaded from anywhere. We're supporting .NET, and we can actually run with any of the 40 or so .NET languages. Here you see a little object designer that lets you edit the XML, turning one kind of object into another kind of an object. And you can do that by modifying parameters in the XML, changing the code snippet that will get executed, extending one kind of object into another. So that concludes this demo. We're also going to be showing you a second demo. You'll have to click separately to the link that will start it, showing you how Live Objects integrates with Office automation tools such as spreadsheets and databases. Thanks very much, and I do hope you'll give the technology a try. Everything you've seen today can be downloaded from Cornell and used for free. Obviously, it's more suited right now for teaching environments than for production settings, but we're going to get there. Thank you very much.